Good morning, second period. I just wanted to say hi before I go over these problems with you. Hope everything is good back at school, and I'll see you guys on Monday. All right, let's knock these out. So, um, our exponents rules. As usual, there's often different orders we can do. This is like number one, we could knock out those twos right away from the numerator and the denominator. I think I'm going to go ahead and do the exponent first, but you could knock out these twos right away. That's one possibility. But let's take care of this set of parentheses here first. So we have 2u cubed times. Now, everything in this set of parentheses needs to get cubed. So this 2 needs to be cubed. And what is 2 cubed? That is 8. So again, we got this 8 from taking 2 and cubing it. 2 times 2 times 2. U squared cubed, multiply the exponents. So that would be u to the 6th. And v to the negative 3rd cubed, that would be v to the negative 9th. And that is over 2uv to the negative 2nd. All right, I'm going to put everything together in the numerator. And then I will simplify from there. So what do we have here? We have 2 times 8, 16. And then u cubed times u to the 6th. That's u to the 9th. And then we have v to the negative 9th. And that's all over 2uv to the negative 2nd. All right, what can we do from here? 16 divided by 2. We know that goes down to 8. So let's go ahead and set up a fraction bar. We have 8 in the numerator. We have u to the 9th over u. Well, where does u have a bigger power? Up top. So that's where the u is going to end up. What's 9 minus the 1 that's there? That's 8. And both of our v's have negative exponents, so we're going to end up flipping those. For the sake of space, I'm going to flip them here and just get our final answer below. So this one goes down. Let's change colors just so it stands out and becomes v to the 9th. And this one flips up and becomes v to the 2nd. Now, where does v have a bigger power? In the denominator. So that's where v is going to end up. How much bigger? 9 minus 2, 7. So 8u to the 8th over v to the 7th. All right, number 2. Let's see if I can fit this all in here. I may have to work backwards a little bit, but let's see. So we've got a large set of parentheses raised to a power here, but there's other stuff inside that we can combine first. So that's what we're going to do. We'll save that negative 3 until the very end. You could, go with the negative 3 from the beginning, but I think it would be easier to clean all this up first. All right, so let's take care of this inner set of parentheses first. So the 2 into the 4th is going to stay the same. And we have over 2m. Now, n to the 0, that equals 1. So all we have here is really 2m times 1. Just going to cross that out. Now, everything in this set of parentheses needs to get raised to the 4th power. So 2 gets raised to the 4th power. Well, 2 to the 4th is 16. Then m to the negative 1st gets raised to the 4th. That would be m to the negative 4th. And then n to the 4th gets raised to the 4th. So that would be n to the 16th. Okay, and all of this is raised to the negative 3rd power. All right, let's clean up in here as much as we can. So one thing I'm going to do is cross out these 2's. A 2 over 2 goes away. We know that. Then we have an n to the 4th in the numerator and an n to the 16th in the denominator. So where does n have a bigger power in the denominator? By how much? 16 minus 4, that's 12. So I'm just going to cross these off since we've kind of taken care of them. We still have a 16. That's going to go out front. And we don't have any m's up top. We have m to the 1st here, and then m to the negative 4th on the bottom. Well, where does that m to the negative 4th end up? Because it's negative, it'll flip up as m to the positive 4th. So now looking at our two m's, we'll basically apply the division rule there. M has a bigger power in the numerator, so that's where it ends up. 4 minus 1 gives us 3. All right, now all of that needs to get raised to the negative 3rd power. So I think I mentioned this in class the other day, but instead of raising it to the negative 3rd power, what I'm going to do is take this fraction and flip it. So 16 into the 12th over m cubed. Then it'll all be raised to the positive 3rd power when we flip it. Now we just need to raise everything in the parentheses to the 3rd power. 16 cubed, well, that's going to be 16 times 16 times 16. And that is 4,096. And then n to the 12th cubed will be n to the 12 times 3, or 36, over m cubed cubed. That would be m to the 9th. All right. Moving on to number 3. So let's combine the y's in the numerator and then apply that 3 there to everything inside the exponent in the denominator, and we'll go from there. So y to the negative 3rd times y to the 1st is going to be y to the negative 2nd. Now we'll put my coefficient out front. So 2y to the negative 2nd, x to the negative 3rd, and then everything in this set of parentheses gets cubed. So 2 cubed, we talked about that on a previous problem, is 8. X to the negative 3rd cubed is x to the negative 9th. Y squared cubed is y to the 6th. All right, let's combine what we can. 2/8 simplifies down to 1/4. Are we going to need that 1 in the numerator? Probably not. We'll see if something else ends up there. So let's look at our x's now. We have x to the negative 9th, x to the negative 3rd, both negatives. So let's go ahead and flip them. So the negative 9 comes up top as a positive 9. The negative 3 goes to the bottom as a positive 3. Let's see here. Our y to the negative 2nd from the top is going to have to go to the bottom. Our y to the 6th will stay since it's positive. So here's that y to the negative 2nd becoming positive when we flip it down. All right, I think we're ready for our final answer. I can see we're going to have x's up top, so I won't need that 1 anymore. X has a bigger exponent in the numerator by 6, so we have x to the 6th up top, 4 on the bottom. Y to the 6th combined with y squared, the multiplication rule is y to the 8th. So there you go, x to the 6th over 4y to the 8th. Moving on to number 4. Let's see what we have here. We've got a couple sets of parentheses with exponents, so it looks like we're going to do this and all of this first, then combine those before we combine with the denominator. So everything in this set of parentheses needs to get squared. So 2 gets squared. That would be 4. X to the negative 3rd gets squared. That would be x to the negative 6th. We're going to multiply that by x to the negative 2nd to the 4th. It turns into x to the negative 8th. Y cubed to the 4th, that's y to the 12th. And then the denominator doesn't change. 2xy squared. All right, let's combine what we can up top. So 4 times the coefficient of 1 there, we got 4. x to the negative 6 times x to the negative 8. That's x to the negative 14th. No y's to combine with this one. Y to the 12th over 2 xy squared. All right, 4 divided by 2. That is 2. X to the negative 14th needs to get flipped to the denominator since it has a negative exponent. There's an x already there. X to the positive 14th goes down with it. Both of our y's have positive exponents, so we're ready to combine those. Y has a bigger power up top. 12 minus 2 by 10, so 2y to the 10th. One little extra step we got to do here. So 2y to the 10th over x to the first times x to the 14th is x to the 15th. 2y to the 10th over x to the 15th. All right, let's look at number 5. So we've got to take care of that parentheses in the denominator there, where everything is raised to the negative second power. So our numerator is going to stay the same. And everything is going to get raised to the negative second. So 2 gets raised to the negative second. X to the negative second gets raised to the negative second. So when you multiply those exponents, you get a positive 4. Y, let's kind of do two things at once here. What's y cubed times y to the negative second through the multiplication rule? That's going to be y to the first when we combine these two. Then when you raise that to the negative second, you're going to get y to the negative second. You could have done them each separately and got a negative 6 and a positive 4. You would still get a negative 2 out of that. All right, let's move some stuff around. So this x to the negative 4th goes to the denominator because it was negative. There's an x to the 4th already down there. 2 to the negative second gets moved up, and exponent goes positive. Y to the negative second moves up, exponent becomes positive. And I think we can get to the final answer in this step. What is 2 squared? 4. Y squared is y squared, nothing in the denominator to combine with it, so y squared, x to the 4th times x to the 4th in the denominator leaves us with x to the 8th. All right, last one of the exponents problems. Raise everything in this set of parentheses to the second, so u squared squared, that is u to the 4th. Move that over to the left a little more, just so I make sure I have enough room. So u squared squared, that's u to the 4th. V to the 4th squared is v to the 8th. Everything in this set of parentheses gets raised to the negative 4th power. So u, 2 times negative 4, negative 8. V, 3 times negative 4, negative 12. And times 2u to the negative second, v to the negative first. All right. We'll combine anything we can here in the denominator first. So I'm going to leave the numerator the same, u to the 4th, v to the 8th, over 2, u to the negative 8, u to the negative second. Add those up. That's u negative 10, v negative 12, and v negative 1 gives us v to the negative 13th. All right. Let's flip these negative exponents up and see where we end up. So I've got a u to the 4th up top, and then this u to the negative 10th is going to flip up because it was negative, so positive 10. I have a v to the 8th in the numerator. This v to the negative 13th will flip up as a positive, and the only thing left in the denominator is a 2. All right, let's combine those for our final answer. U to the 4th times u to the 10th is u to the 14th. V to the 8th times v to the 13th is v to the 21st, and that's over 2. All right, let's move on to our radicals problems. Okay, how can we split up the square root of 192? 64 goes into 192, so you could split it up into root 64 times root 3, which would be 8 root 3. Yeah, let's suppose you didn't find or didn't really realize 64 went into it. You could have divided by 2. So another route to get to the answer would be 96 and 2. And then, I'm just kind of familiar with 96. I know that goes into 16 and 6. I still have this 2 here. And, I know that root 2 is going to be one of my factors of root 6, which would give me a pair here. So that's kind of what I'm doing mentally. I have a root 16, root 3, root 2, and then this root 2 comes down. I know the square root of 16 is 4. A pair of root 2's is 2 on the outside, root 3 underneath. So, same thing, 8 root 3. All right, root 112. My first thought on this one is 4. I know 4 goes into it, so when I figure out how many times it goes into it, it goes in 28 times. Well, then I see there's a 4 in this as well, so I'm going to split that out. Root 4, root 4, root 7. Well, a pair of root 4's is equal to a 4 on the outside, root 7. Now, the fact that I got 4 on the, for a coefficient tells me 16 would have gone into it from the beginning. So the quickest way to the answer would have been root 16 times root 7, or 4 root 7. All right, number 9. 147. That's one I've simplified numerous times over the years, so I'm pretty familiar with that one. I know it's 49. 49. It goes into it 3 times. Got an odd exponent, so I need to knock it down 1. 1 times x, that's even, so it's good to go. All right, we're ready for our final answer. What's the square root of 49? 7. 3 underneath, square root of x squared, x. Even this with 1x underneath the square root of y to the 4th, y squared. So 7xy squared root 3x. All right, root 245, that's another 49. 49 goes into 245 5 times. We've got a root x. Can't break that down any. This is even. Don't need to break it down any. Answer time. Square root of 49, 7. 5 underneath. X underneath the square root of y to the 4th. Y squared. So we get 7y squared root 5x. All right, moving on. 11. Negative 3 root 12 plus 3 root 12 gives us 0. Yes, it's 0 root 12, but you don't need to write that. Just 0. Negative 3 root 18 minus 2 root 18. Can't combine them as they are, so we'll simplify each of the radical portions. So negative 3, that root 18 goes to root 9 root 2, and the root 8 goes to root 4 root 2. So negative 3 times the value of root 9 is 3, then root 2, or negative 9 root 2. Here we have negative 2, value of root 4 is 2, then root 2, so we have negative 4 root 2, and grand total of negative 13 root 2 on that one. Okay, 13, 2 root 54 minus square root 24 plus 3 root 2. Can't combine anything as they are, so let's simplify what we can. 2 root 9 root 6. This will be root 4 root 6 plus 3 root 2. Let's go ahead and kind of skip this middle step. We know this is going to be 3, and this 3 times the 2 already out is going to be 6 root 6. Minus, we know that's 2 root 6 plus 3 root 2. These are like radicals, so we'll go ahead and combine them. 6 root 6 minus 2 root 6, 4 root 6 plus 3 root 2. All right, simplify. Root 20 goes to root 4 root 5. Root 8 goes to root 4 root 2, and then this stays the same. We know the square root of 4 is 2. Multiplied by this negative 3 out here is negative 6 root 5. And we know the square root of 4 is 2 times this 2 is minus 4 root 2 minus 3 root 2. Final answer, negative 6 root 5 minus 7 root 2. All right, moving on to some multiplication. Multiply the coefficients out front. 4 times negative 3, negative 12. This is a perfect square, so we could have evaluated it from the beginning, but we'll go ahead and multiply root 4 times root 8, root 32. So we just need to simplify the radical portion. That is negative 12, and we split up 32 into 16 and 2. We know that the square root of 16 is really what? 4. So negative 12 times 4, negative 48, root 2. All right, root 2 times root 2. Yes, we know that's root 4, but I really want you to skip that step and just go right to 2. Anytime you multiply a radical by itself, it will just equal the number underneath. All right, a little distributive property here on number 17. Square root of 5 times the square root of 10 is root 50. Root 5 times 3 is 3 root 5. Now we just need to simplify this. That becomes 25 and 2. That's 3 root 5. The square root of 25 is 5 root 2 plus 3 root 5. Can't go any further than that. More distribution on number 18. Root 2 times 5, that's 5 root 2. Root 2 times root 3, that's root 6. Can we split up root 6? No. So final answer. All right, some division. 5 root 5 divided by 3 root 3. Can't simplify anything really. The only thing we can do is rationalize the denominator. Remember, we're not allowed to have an irrational number in the denominator. We get rid of that square root 3 in the denominator by multiplying by itself. It must multiply also in the numerator. So what do we get up top now? 5 root 15. What does that give us on the bottom? That gives us 3 times root 9, which is really 3 times 3, or 9 in the denominator. So just this portion, root 3 times root 3 is 3 times the 3 that was out front, gives us 9. Can't simplify 5/9, can't simplify radical 15. Done. Well, let's see, number 20, the only thing there is to do is to rationalize the denominator. Multiply by root 5 up top. We get negative 2 root 5 over 5. All right, 21, 4 root 3 over root 2. Got to rationalize that denominator. Multiply by root 2, multiply by root 2. What does that give us? 4 root 6 over 2. We can simplify 4 over 2 here. What's 4 divided by 2? It's 2. 2 over 1, we don't need the over 1. Final answer, 2 root 6. All right, number 22. There's a couple ways to approach this one. The root 4 is a perfect square. You can evaluate that. 4 over 20 can be simplified. I think I'm going to go that route just so that I end up with a smaller denominator. So I'm going to divide both of these by radical 4 is what I'm doing here. So that gives me, let's go over here, 5. Radical 4 divided by radical 4 is radical 1. And root 20 divided by root 4 is root 5. Well, what's the square root of 1? 1. So 1 times 5 gives us 5 up top. Now I do need to rationalize that root 5 in the denominator. So I multiply by root 5 and root 5. So that just gives me a root 5 up top and a regular 5 on the bottom. Root 5 times root 5 is 5. What happens to 5 over 5? Just cancels. Final answer on that one, root 5. All right, 2 more. 3 over 5. Can we simplify that? No. 4, 5, no. Now we do have an m squared over m squared. Anytime you divide something by itself, it equals 1. So those just go away. So that takes us to 3 root 4 over 5 root 5. Well, we know what root 4 is. That's 2. So up top, we really have 2 times 3, or 6 over 5 root 5. We just need to rationalize the denominator. Multiply by root 5 and root 5. Up top, we get 6 root 5. On the bottom, we have 5 times, what's root 5 times root 5? That's just 5. So 5 times 5, 25. All right, last one. 3 over 4 can't do anything with that. 15 and 10 are both divisible by 5. So I'm going to divide in my head by radical 5. Radical 5. So let's see, we've got our 3 over 4. 15 divided by 5 is going to give us root 3. 10 divided by root 5 is going to give us root 2. Now, r cubed divided by r squared, through the division rule, we just subtract. That will be r to the first. So really the only thing we can do at this point is rationalize the denominator. So we multiply by root 2, multiply by root 2. That gives us 3 root 6r up top. 3 root 6r. And then in the denominator, what's root 2 times root 2? That together is just 2, and 4 times 2 is 8. So we end up with 3 root 6r over 8. All right, that does it. Good luck on your quiz.